Test one, two. All right, we're live. Thank you guys so much for coming today. Really excited. Gave this workshop a few weeks ago. Pretty well received. Hopefully you get some value out of this today. The goal is really to give you guys like a full kind of overview of like what a full stack dapp really is and how to kind of properly develop full stack dapp. We're going to be focusing on scaffold E2 and the graph. A little bit about me. I am currently a DevRel engineer working for EdgeNode. I'm also the organizer of the meetup group. Some of you, by the way, hands, who's in the meetup group? So we got a few meetup groups, and we got some people that are just here. We kind of co-promoted it, so it's just good to know who's here. Yeah, I'm also a core member of the Build Guild, or the Biddle Giddle, as you guys may have heard it before, supporting Scaffold ETH. So I do a lot of work promoting like development around Scaffold ETH as a toolkit, and it's really powerful. Who here has used Scaffold ETH before? Anyone? A couple people? Awesome, cool. All right, so that's good to know. So this is open source workshop, so it's available here. You can just either go to bit.ly/fullstackdapp, or you can scan this QR code. But this is going to be a pretty thorough workshop. The goal is to try to go through it with you and kind of show the steps as we do it, and kind of get you guys comfortable with the process of the solution. We're going to start out by actually kind of going over a little bit about the graph and talking about like why the graph is a good solution for if you're building a full stack dapp. And then we're going to kind of just dive in and do it. So it's going to be a few slides, and then we'll get kind of into the nitty gritty. So I don't know why for some reason this always gets stuck there. All right, here we go. So I think everyone has a basic understanding of what a smart contract is, but I think it makes sense to put it in the context of kind of what we're building. Who here would say they're a smart contract developer? Hand raise hands. Who here is like aspiring to be a smart contract developer, and you kind of want to be able to build dapps? Is something they're interested in. The general concept of a smart contract is you're deploying a piece of code onto the blockchain with the hopes that it is a immutable piece of code that you're going to deploy. And most commonly, when we think of it in like general terms of like data, it's really just a data store for state changes, right? So if we look at like a popular example, this is the CryptoPunks NFT, which is a ERC 721. It's a really basic smart contract, but it does have a lot of power and it has a lot of grit behind it. It was essentially a catalyst for NFTs to be somewhat popular. But if we look at the actual data, really on the underlying aspects, it's keeping track of the IDs, the owner of the actual NFT, and then the place to where to look up the metadata URI, the NFT metadata, right? It's pretty simple. It's just a state storage for these NFTs. And so if we think about if we propose transactions and we propose a transaction to our smart contract, if you're a good smart contract developer, you are probably emitting events, right? You're keeping track of what's going on in your smart contract by publishing these transaction data in events so that your front end can be aware of that, or anyone listening to the contract that wants to keep track of what's going on with it into this event data. And so, but there is one problem with particularly the blockchain. The general idea is you build a dapp, and at first, like the concept was, okay, you have a smart contract that is deployed to the blockchain, and then you have a user interface that is interacting with that dapp, right? And you are doing reads and writes from the blockchain. Okay, so if you want to propose a transaction, you write that to the blockchain using cryptography. If you want to read that information, you can read it using an RPC call, right? You can actually query it and get the data that you want for the current state of what you're interested in. But there's one problem, is that the current architecture for most blockchains are really mostly incentivized for writing data and not necessarily incentivized for reading data. Okay, the way that they're just set up with the consensus algorithm is they're designed to secure a transaction that you propose to the network. And so what we see is like the original concept of a dapp was you would just make your ETH calls to your blockchain to get the data you care about and then put that into your UI. But that becomes a problem when you're trying to get large amounts of information, or if you're trying to get different points of time inside of what happened within the smart contract, like different transactions. And so there's just this kind of like missing link. And you also have this issue of provenance, like I mentioned before. If you want to know historically, like what happened with a specific punk or a specific NFT, or if you want to see a certain transaction that happened at a certain point in time, you would have to know the block number to make a request to get that data. And you probably need to think about, oh, maybe I need to do like some kind of database to keep track of this stuff. And so this becomes a problem, because then you're reverting to some of the Web 2 style architecture. And we want to build things in a Web 3 decentralized open way, right? And so we can think of it like time machine on a Mac, right? In a time machine on Mac, you can go back in time and you can see the state changes to this particular, in this example, we have just a Excel file that we're making changes to, but it's the same concept. Is like we want to get that historical data, right? And so this is actually some code that we saw running in the wild, where someone wanted to get a list of all of the NFTs that a specific wallet that was connected to had in their wallet. And so you're ended up with having to, if you want to use like ETH calls and you want to actually query the smart contract, you have to do this kind of like looping and iteration. And this is okay if the wallet only contains like a few NFTs. You can think like each call might take like 100 milliseconds. But as you start to have lots of NFTs in the wallet, this could easily take 10 seconds, 20 seconds. The more NFTs the user had, the longer it would take to load. And it's just not really clean code as well. It's very difficult to understand what's going on here, and it's complex to write as well. And so this is where the graph kind of comes in. Who here has kind of heard of the graph before? Has anyone built a subgraph actually? Raise your hand. Cool, we have some subgraph developers. That's awesome. So the graph is a decentralized network, and it currently serves anywhere between 1 to 2 billion queries per day for data about blockchain specifically, in a easy to read GraphQL kind of interface. It is a decentralized network, and so there's, I think last time I checked, there was over 400 indexers running copies of various subgraphs, and we'll get into what a subgraph is, but various information that's available for certain dApps or certain smart contracts. And so the better architecture for a dapp is actually to do something like this, where you have a middleware layer where you are doing indexing. So your user interface can still be incentivized to make transactions to the blockchain, but for reading the data from the blockchain, you index that data into an index protocol like the graph, and you can essentially do a more beautiful way to query the data, easier way to query the data using GraphQL. I don't have an example of what that looks like, but we're going to build it out using GraphQL, and I'm going to show you some queries of how they work. So we're going to get right into the code now. But before I get started, does anyone have any questions or concerns about anything? No? Okay. All right, let's get going. Okay, so as I mentioned before, this is open source. So if you went to bit.ly/fullstackworkshop, you'll get here. Scaffold ETH is a open source tool. So it was originally created as kind of like this problem where, like, if you're getting started with building on Ethereum, there's all sorts of different tools to choose from. There's all sorts of different ways that you can build a dapp. Scaffold ETH kind of makes some assumptions for you and kind of chooses some tools for you to use. So it's designed to use, it's not listed here, but oh yeah, here we go. It uses Hardhat as a virtual chain. It uses Next.js with TypeScript support. It uses RainbowKit, and then it also uses WAGMI, which is like a front-end kind of component that you can essentially query the blockchain with using that. So we're going to use Scaffold ETH for this. There is a special repository. So as it stands today, there's a special package called the subgraph package. Okay. And this subgraph package is pretty much identical to the existing Scaffold ETH2, but it also has a Dockerized instance and a setup for you so that you can run the graph locally inside of Docker. Okay, so you could technically deploy your subgraph to what's called the Subgraph Studio, but we're going to focus for the first part of our workshop on deploying it locally so that you can do some iteration testing. So when you first get Scaffold ETH, and by the way, this was recorded last time. There's a recording. This is also being recorded, so you guys can always come back and watch this later. Scaffold ETH, we're going to need Node.js installed on the computer. We're also going to need Yarn, which is like a package manager. Yarn is really useful because it comes with a lot of scripting functionality. So Scaffold ETH has already written a lot of like easy to use commands for you using Yarn so that you don't have to like memorize the full commands to type. And then obviously you need Git to be able to check out the repository. And then you need Docker if you want to do the graph portion of what we're going to do. So there's a little bit detail about what Scaffold ETH is, what the benefits are. We're going to do a demo and show you guys why it's so powerful, and then we're going to. And this is also some information about the graph. But what we're going to do first is, and I've already done it actually, is we're going to clone the repository, Scaffold ETH repository, into a new directory, and then we're going to use the clone -b command, which is just a certain branch, and we're going to grab that subgraph package. Okay, I've gone ahead and basically did that. Can you guys see this okay back in the back? Yeah? Okay. So I've already cloned the repository. We have it here. And I've already also gone ahead and did Yarn install. It takes about, I don't know, maybe like a minute, depending on your machine. And it's basically going to go out. And the beauty of a Yarn package is it's going to install all the dependencies for you. Okay. And then we can just do a Yarn chain to actually spin up Hardhat. There is a build of Scaffold ETH that also comes with, oh, Marty, I need to shut this down one second. Sorry, I was testing in a different thing, so let me just stop that real quick. Okay. Okay, so where was that? Okay, Yarn chain. So there is a special build of Scaffold ETH that you can execute from an npx command. So if you go to, I'm just going to show you this to you for the future. So if you're building a dapp, you can either clone the repository, like I'm doing, or you can use the npx command. npx is like a way for you to initiate a directory without having to do any kind of git checkout. It just installs it based off of the npx package. So there is a create-eth package that you can also run. If you prefer Foundry, you can actually run this command here, and you can spin up Foundry instead of Hardhat if you prefer. But what we're going to do today is all going to be based around Hardhat. So we can come here, and now we can see on our first window. So everything you kind of do in Scaffold ETH, you always have a lot of windows open because you need your chain up, and then you also need to have your front end up. So we're going to open up this second window. I'm using what's called tmux, which is just a terminal multiplexer. It allows me to split my screen on one terminal. You can do this in separate windows. It's fine. It's kind of up to you. But this next one, we're going to do Yarn start. So we've got our blockchain running. It's got these kind of like 20 accounts that are kind of like starter accounts for us that have some play ETH in there. Then we're going to start up our front end in this window. And you're always going to kind of keep those open, right? Those are kind of always running. Then in these other windows is where you're going to do the graph setup and is where you're going to do your deploys. Okay, so in this next window, there's a couple commands. The first one is yarn clean node, which will go out and just make sure that basically your graph directory is completely clean and empty. It just removes anything there. And then you can just do yarn run node. That's it. And what that's going to do is it's going to grab the Docker compose file that's there already for you written, and it's just going to spin it up in Docker. So if anyone hasn't heard of Docker, Docker is just like a container management system. So it allows you to run these virtual kind of containers that do different tasks. So let's take a quick look at that actually real quick and show you what it looks like. So let's go here. Let's go to packages. So this is the Scaffold ETH repository. You'll see here in the packages folder, there's 3 folders. It's a mono repo. So the way it's set up is it has this main package, which is the main kind of Yarn package. And then everything is referenced in these separate workspaces, okay? So we'll see here that we have 3 different workspaces. We have our Hardhat workspace, which is our backend, right? Our smart contract deployments are gonna go in there. We have Next.js, which is our front end. And then we have the subgraph package, which is basically all the subgraph configuration. So it's already kind of written for you. I just want to show real quick the graph node and the Docker compose file. So the stack for the graph, if you're an indexer and you're running the graph, you're running 3 different things. You're running a Postgres database to store the data. you're running graph node, which is the workhorse for the graph. It's what indexes the data and processes the events and stores them. And then you're also running a copy of IPFS to store the manifests and all the data. You don't need to understand what this Docker Compose file is, but it's good to know if you are trying to troubleshoot something, like you can't maybe reach a container or something, you could look in here. There's a lot of stuff that's pretty much already in here. The only thing I will say is there is this thing for the locale that if you're running Windows, you might need to remove this line if you're running Windows. Anyone running Windows? Okay, so just keep that in mind. If you get any error about locale, you might have to remove this environment variable, okay? But you don't need to know much about Docker. All that it's running the containers for you. And we can see that they're already up and running. So now we have our hard hat container running, or we have our hard hat instance running. We have our front end in Next.js with TypeScript, and then we have our graph node, our IPFS, and pretty much everything we need for the graph running locally here. So now we can start simulating using the graph in our dapp, okay? So at this point, we've just kind of set everything up. We haven't actually deployed our contract yet, but let's just go in real quick and take a look at what scaffold ETH looks like, okay? So it runs on port 3000, and the beauty of scaffold ETH is a couple things. One is it comes with a lot of boilerplate code written for you. Like, as you can see, it's very, very beautiful. It's got some cool styling already built into there. It's got some components, some ETH hooks, some various stuff. But if we look at this first page is kind of just like a welcome screen. It's just some information. There's actually nothing here. It's got like the night and day toggle. But what's important right here is this debug contracts folder. So we don't have a contract deployed yet because we haven't actually deployed our contract. So let's go ahead and do that real quick. So in this fourth window here, we're going to do a yarn deploy. That's it. So scaffold ETH does come with a smart contract. It's going to take it, it's going to compile it down, build the ABI, essentially inject the ABI in the front end for us. The ABI is basically what's called the application binary interface. When you compile a smart contract, it compiles down into bytecode. It's not human readable, so you wouldn't be able to look at the bytecode unless you're like, I don't know, a genius maybe. I don't know, there's some kind of way you could do it. But for the most part, you're not going to be able to understand what's going on. So you need this ABI, and the same goes for your front end. Your front end needs an ABI to know how to interact with your smart contract. So the beauty of scaffold ETH is it takes your ABI for you and injects it for you, and then it builds out all of this stuff for you. So it builds out the readers and the writer functions for you, the UI, and it allows you to start interacting with your smart contract, okay? And it also builds fields for the variables, and like in this case, we have a string right here called building unstoppable apps. So it's called greeting, but the value for it is building unstoppable apps. We have the owner, we have the premium, which is like a Boolean, and then we have a counter that's keeping track of stuff. We can see our contract address here. We can see if it has any value. We can see what network we're on. And the next thing you'll notice is, like, let's say I want to change the greeting. So the current greeting is this, right? And we'll look at the smart contract in a second. But let's say I want to change it to House of Web3 like this. And I can't type today. Okay. And then I want to hit send. It's going to tell me, well, I don't have the funds to pay for this transaction. I can't pay for the gas. So the next thing you'll notice about scaffold ETH is it comes with this concept of burner wallets. So I can just click this little button, grab some funds from the faucet, and those get transferred from Hardhat into my wallet inside of the browser. So you can see here I have this kind of like green, pink, kind of blocky dude guy. If I was to say new incognito window and go to that same website, then I get this new identity right inside the browser, a new wallet. And I could grab funds from there if I wanted to as well. And so I can kind of use that as to my advantage because I can start kind of testing my smart contract between two wallets without having to connect to MetaMask or any other wallet. There are some caveats if you use MetaMask that you have this thing called a nonce, and the nonce keeps track of like how many transactions you make, and it's a safety mechanism for Ethereum. And if your nonce goes like out of sync with the dapp, it has errors. And so the idea is that we don't need to use MetaMask at all. We can just use these burner wallets. So now I can hit send, and then we can see that I updated the state. So just like I told you before, a smart contract is really just well, the Ethereum virtual machine is a state machine. It's really designed to keep track of state, keep track of changes, and so your smart contract is the catalyst for that. So now we have this change. So that's all fine and dandy. That's really good. There's also this example UI, which has like some examples. You can see here, we're like getting the data. We have a counter. We also see here that in this transaction, we're sending some value into the smart contract along with the gas. Not going to get too much into gas, but you do every time you make a transaction on the blockchain, you have to pay the gas, which is the power that powers the Ethereum virtual machine. So the same thing goes for locally. We need to pay that gas. So here we're paying some value plus the gas. So if I do this now and I say like San Francisco, like that, and hit send, then we can go back to our debug contracts folder and we can see that also our contract started to get some value. So now our contract is kind of acting as a bank because we've transferred some funds into the smart contract for that. So let's just kind of go back to the mono repo here. Let's take a look. First, let's look at hard hat. So we have the contracts folder here, and we have this your contract.sol. So that's the default contract that comes with Scaffold ETH. And we can see everything that we see in the front end is here. We have the string, we have the Boolean, we have the counter, we have a mapping that we keep track of, which keeps track of like addresses and how many times they've submitted something to a function. We also have these events. So you see these events. We have a greeting change event. An event is pretty much any time in your dapp that something happens, you want to emit an event for a couple of reasons. One is you want to log that in some way on the in your dapp essentially, or you might also, want to let your front end know that something happened, right? So you might subscribe to those events and see that stuff. And those are important because that's what the graph uses to index data. We're going to grab those events, and we'll get to that in a second. But you can see here, we don't really have any, there's a lot going on here, but for the most part, the main function of this contract is it's kind of like a greeting function. It allows us to pass in a string over memory called new greeting. It's a publicly available one. It's payable. That's how we were able to send some value there. And we do some like logging. This is interesting as well. Like because we're using hard hat right here, we're importing the console. It allows us to do console logging. We're also logging the information inside of the log, so it shows up over here, which is really useful for debugging. If you're trying to debug something, you can just log it there. But for the most part, this is the thing that it's doing. It's just changing the greeting, adding to the counter, keeping track of the mapping, which is a more complex way to store data. But for the most part, it's a pretty simple contract. Okay, so let's go back to our workshop and see kind of where we've come. So if we go to, oh, it's right here. So if we go here, we checked out the repository, we did the install, we spun up the chain, we spun up the front end, we did the deploy, then we cleaned out any data, and then we ran the graph. So we actually have the graph running right now at this point. The next step is we want to take our existing contract and we want to build out essentially a subgraph configuration for it. Okay, this is where it gets a little more technical, but I'm going to walk you guys through exactly what a subgraph is and how it's kind of configured. There's three components to a subgraph configuration that are the critical components. The first is the subgraph YAML. Okay, so you can think of the subgraph YAML as what ties the entire subgraph together. And what's most important on the subgraph is what the name of the ABI is, because just like your front end needs an ABI, the graph needs an ABI to know what events that we care about. So it's going to need to read in to see what events are available. And then also, we have this concept of entities, which I'll get to in a second. But entities, you can think of them as how you want to store the data for your events. Okay, and then we have these things called handlers. So this is considered like the manifest, which kind of like tells us exactly what contract we care about. We care about what network we're on, right? So we're just doing everything localhost. If we were on a test net like Goerli or Sepolia, we would change that. If we're on mainnet, we would probably use Ethereum. But for the most part, this is already written for you. So you don't really need to know right away how it works, but I want to guys walk you through it. And then the important thing is this handler. So this is how we want to store the data, or what I should say, these are the data storage objects that we want to store. And then this is like what needs to run in order to handle those events. So you can imagine that every time someone changes the greeting, right, we want to keep track of who that was, what address it was, what their new greeting was, whether they had a Boolean of true or false, whether they paid some value in, and then maybe like their counter. This is their existing counter. And so we can look now inside of the greeting. First, let's look at the schema. So again, you can think of the schema as this. If anyone's ever used GraphQL, this is very similar. It pretty much follows the same concept, but it's a GraphQL schema that is designed to keep track of how you want to store your data on the graph. So in our case, we care about two things. We care about what the greeting is, and then we also care about who actually sent that greeting, right? And when we're passing that stuff across inside of the thing here, we get an address, we get a string, we get a Boolean, and we get a few things here that are in the event. And so if we go back to our schema, we can also see that we want to keep track of that stuff. So the greeting, the premium, the Boolean, the value, how much they paid. And then we also keep track of some other stuff like the transaction hash, which is the actual Ethereum transaction. And again, these are just data objects. So you can think of them as just like a database. These are the things you care about inside of that data structure. So this is all defined for us already as well. And we're using this derived from, which is a more complex subject, but we're basically doing some relationship data to keep these in sync. We're not going to get into that too much, but the important thing to know is we have two different forms of data. And then we got the mappings file. So the mappings, they're also called handlers. In this case, we're calling the handler the mapping.ts. If you've ever written JavaScript or TypeScript, this will look very familiar. This is assembly script, so it's a subset of TypeScript. And it allows us to essentially, when we deploy our subgraph based on these three configuration files, and we deploy it to the graph node, this gets compiled down into WASM, and it runs constantly. So it's going to be running this logic for you and listening for these events for you, and then saving that data automatically for you into Postgres. Okay, so you can think of this as kind of like the workhorse of the graph, and it's obviously defined by what you care about and how you want to store this data. And we're not going to get too much into this because, again, it's already written for you out of the box to index this data. But we can see here that what we're doing is we have this handler, and we're passing in the event called greeting change. And then we're grabbing some things like who was the setter, converting it to a hex string. And then we're going through here to see if it was null. And if it was null, we set some variables. But basically, at the end of the day here, we save the data. So we do a dot save, and then that will actually save the data to Postgres for us. Okay, so you can kind of think of this as like the workhorse to actually process these events. So let's just assume if you don't know how this all works, that's okay. Let's just try to deploy our subgraph. Okay, so we have it working. We have our local instance of the graph running, hard hat. We have our front end. So the next point is we've deployed our smart contract, but now we need to deploy our graph configuration. So how do we do that? So there's a yarn command for it, and it's yarn local create to create the subgraph. So what that's going to do is going to take the current subgraph. It's going to build it, and then it's not going to build it, but it's going to publish it, and then we're going to do a local ship. So just with those two commands, we take those three files, wrap them up essentially into we ship them into the graph node, and we ship the manifest into IPFS, and we compile it, and then it asks for a version label. Okay, so just like you make changes to an application, as you make changes to your application or to your smart contract, you'll probably want to update the subgraph. So this can be a version that you keep track of as you make iterations on your smart contract. You'll want to update this info. So let's just do 0.0.1, which is like the very first one, right? And send that. So let's load it up here, and let's see what we got. So it gives us a query endpoint, okay? So we can grab that and then come over here to our front end or to our browser and go there. So then it builds this, it deploys this for you as well, which is like a kind of like an explorer for GraphQL. And it's automatically pointing at our instance in Docker. It's running on port 8000. And we can go to Explore. And because we're using GraphQL to store the data, we can start exploring the data schema type, so the entities. And so we have the greetings, but then we have the greeting and the sender, but we also have the greetings and we have the senders. So we could go to greetings and then grab the ID, the premium, maybe if they had any value, and hit play. And then we start to get those values. And then we can also say who the sender was, what the actual greeting was, like this. So here we go. So we have two different results, House of Web3 and then San Francisco. So those were the changes I made. So what happened is when I deployed my subgraph, it went back and it parsed through all of the data in Hardhat by using RPC calls. So it went out and grabbed all the data, ingested it using the handler, and then stored it inside of GraphQL for us. And then now we have this easy to query language that we can just put into our front end, okay? So real quick, let's kind of just dive a little bit into the front end, okay? So we've kind of focused on Hardhat, we've focused on the subgraph, but let's take a look at Next.js. So inside of the pages folder, and then inside of example UI, let's think this is where it is. Oh, it's actually under components, sorry. Under components, example UI, and then contract data. We can see that there's already some code in here, right here. So up above, we're right here, we're importing GQL and useQuery from Apollo client. Apollo client is just a component that you can inject in your front end to easily query GraphQL data, okay? So we're ingesting that here as an import. We're importing it, not ingesting it. And then over here, we're creating a query like this. And then we're creating a request of what we want to do using GQL, which is the GraphQL query language. And then we're actually making the query right here with a pull interval of 1,000, which means like every 1,000 milliseconds we're checking. And then we can see here that we're console logging that into the console. So we can go and look at that right now. Let's take a look. If we go to here, sorry, here it is. So if we go to example UI and go to view, developer tools, and go to it's under network. Or no, sorry, it's under console. There we go. Okay, let's refresh. And we can see that here inside of the thing, we have the greetings data. So here we're logging greetings data, and then here's the actual data object, which is GraphQL. And we have access to this data. So if we look in here, we can go to data, we go to greetings, and here we go. We got two different greetings. We can expand those. And I know that's hard to read. Let me kind of open it up. And so the beauty here is that we're able to query the data using GraphQL with just one simple HTTP call, right? As opposed to, let's just say we had 100 greetings that we wanted to change. If we were just doing the standard way of like just RPC calls, we would have to loop through and iterate over our blockchain 100 times, grab the data we care about, parse it, do whatever we want, and then display it in the UI. As opposed to here, we're just doing this simple kind of easy to use kind of GraphQL query that we can customize. Like if we only wanted the first one, we could save it and then refresh and look at it again. And then we're only going to get the one that we care about. See? Just the zero, the key zero, okay? So that's very powerful because we can put all the data that we care about into the graph, and it's available in a decentralized way. We don't need to have a database. We don't need to have, some kind of third-party service that's keeping track of our data. We can literally use the graph to store that data. I'm going to pause for a second and see if anyone has questions, because I know that's kind of a lot, but any questions about that? Kind of make sense? Okay, so let's kind of go back real quick and let's go to the workshop. And so let's kind of recap what we've done. So again, we cleaned up any data that's there. So if you want to reset your instance and kind of clean up whatever's there, you can run that and then run the node. You can also do yarn stop node if you want to stop Docker. And then we created the actual configuration, and then we shipped it with just these two commands. So everything we're kind of doing is local, right? And then we tested it as well. Let's grab this query right here and then check it out, see if it works. There we go. We get the data we want, San Francisco and House of Web 3. So we have this easy to read GraphQL query. Okay, so now let's say we're trying to iterate. Now it kind of gets a little more interesting. We want to add a new event to our smart contract, right? We're learning Solidity. Let's go ahead and do that. Let's go into our front end. Let's go into packages. Let's go into hard hat. Let's go to the contracts. Let's go to your contract. Now what we want to do is just add a new event, okay? And a new function, okay? So we can put it right here. And this is a really like just basic example of a new event we want to do. So we want to have a new function that is going to allow us to send a message on the blockchain from one user to another, from one address to another address. So it's going to be externally available. And when we do that, when we call that function, we want to emit the event. So here we have the event called send message, which is going to keep track of who that message was sent from, where it was actually sent to, and then what the string was, like what was passed on the message, right? And then we're just going to emit that event here. And so we're going to use this message.sender. Anyone who's new to Solidity, when a function is called, there are some global variables that you get access to. And one of those is called the message sender. It's whoever signed the transaction. So here we're emitting the event, whoever signed the transaction, and then whoever they passed it to into the to field, and then we're going to pass the message along as well. And so this is going to be an event. So we want to build this out, and first let's test it. So we got to deploy our new version. So we're going to do yarn deploy. If you ever want to force a deploy, you can do yarn deploy -- reset. And what it'll do is just force a new contract to get deployed. So it's going to compile it, deploy it, and we're good to go. Getting some kind of weird error in my front end. Hopefully it's nothing, nothing big. But let's go back here and let's go to the dapp. So we can close this for now. So let's go to debug contracts. So what happened? We get a new function that we wrote, right? We wrote a new function. So we can say, one of the cool things about Scaffold ETH also is it has this thing like, I want to send Vitalik.eth a message. It will do some ENS resolution for me. So ENS is like the Ethereum name service. So Vitalik.eth is Vitalik. And it does this little population here where it creates his little like his ENS profile icon. And we can send him a message like, hey, what's up? And hit send. So this is all local. So he's not going to actually see this on the blockchain. But I was able to send that message. And then we also got a receipt for the transaction. So we know it was successful. We can see like it was confirmed and all that good stuff. And everything we're doing is locally right now, but we were able to send that message. So now let's assume that we want to get that data in a easier to read way. So let's come over here to our workshop. We've deployed our new instance of the contract. Now we want to update our GraphQL schema. So if we go to our, let me just grab this real quick. We go to hard hat, or sorry, next subgraph. We go to source. So the first thing we'll update is the schema. So right now we're keeping track of the greetings and the sender, right? But we also want to keep track of this stuff. So we can paste this in right below. So these are new data objects now that we're going to keep track of. And the 3 data objects that we care about is what the message was, who the messenger was, who sent the message, and then who the receiver was. So we're just adding these new data objects. And this can be automated, but I want to walk you guys through the process so you kind of see what it looks like. This can be automated using the CLI, and we're going to do that a little later, but I want to show you guys what it would take to make this change. So we're going to save that. Then we have the concept of the manifest, which is the subgraph YAML here. We need to also add the event entities. Well, we need to add the entities that are in our schema, but we also need to add the event handler, right? Because we're going to create a new handler. So we already have these greeting and sender here. We just need to add message, messenger, receiver, which are all coming from here, right? And we need to add the handler. So again, because we are making a new event, then we need an additional handler, right? So in this case, we care about the send message event, and it has three things that get passed along. One address is the from, one address is the to, and one is the string, right? And we call that handle message, and we save that. That's it. So we've made our change to the schema. We've made our change to the manifest. Now we can run these two commands called ABI copy, which is going to copy over the ABI because we deployed a new contract, we have a new ABI, right? The ABI changed. And we also can do a code gen to generate all the code that needs to be deployed on the graph. So these commands come built in, so we can just run that over here. So this is going to copy the ABI and move it over, and then it's going to generate the proper schema stuff. And then we can just add the handler. So now we need to add the handler. So we can go into our mappings file. This is where it gets a little more complex, but we have our mappings.ts right here, right? And we need to make some changes. What do we need to do? We need to first, we need to add the additional send message right here, right below, right? Because we care about send message. And then we also need to grab the messenger receiver. So we can actually just grab this whole thing from the schema, and we can just replace this line right here. So now we're not only are we importing the event, but we're also importing the entities that we defined here in the schema as well into our mapping, so that it knows how to handle this data. And then the last thing we need to do is do this handler. Now the handler is kind of complex. I can kind of walk you through basically what it's doing, but we're just going to add another handler right below here at the bottom. Okay. So we have our existing one, which was keeping track of the greeting change, but now we have this one that's going to handle messages, right? So same thing, we're just grabbing some data from the event that's happening. We're seeing who it's coming from, who it's going to. We're seeing if it exists already. We're loading it in. If it's null, then we create it. And then we also keep track of the counter. So we do some stuff here, but for the most part, at the end, we save all of those entities. And we process the data, and then we save it. So that's it, we save that. Let me just make sure I saved all of these. They're all saved. So we've added our, to the manifest, we've added to our schema, and we've created a new handler. So now we can deploy that change. So we can just go, let me just make sure. Yep, so we just do a local ship. That's it. We don't need to do the gen, the local create, because we already have our instance of iGraphQL running. So we just need to do yarn local dash ship. So that's going to take those three changes I did and push them into the graph. And so now we can do a new version because we've iterated on our subgraph. So we can do 0.0.2 like this. And then it's going to push out a new change. You can see everything's getting processed for us, and we're good to go. So now if we come over here, we can see, let's refresh, we get a bunch of more data, right? Now we still have our greetings, and we still have our senders, but we also have the messengers and the messages, and we have the receivers. So we have these new entity types, these new data objects, and then so now we can start grabbing that stuff. So if we care about like messengers, we can say like the first 5 ID, and then we can see their message count, and then we can also see like the message, right? So who is from, address, and then who is to, address. And we can play, and we get that data. And if we can also get the message too as well if we care about it, which is right here. So hit play. So there we go. We got the message that I sent to Vitalik. So if we were to look up the address here, this is Vitalik's address, and this is actually, that's kind of weird. I don't know why they're the same, actually. That might be a problem with my code. But you get the idea. We're able to get the data we care about based on the programmability of our handler. Okay? Okay, so now we can kind of, I want to take a break and see if anyone has questions. Maybe we can do like a 10 or 15 minute break. But first, Does this kind of make sense? Is this kind of, are you guys following the kind of general consensus of what we're trying to achieve here? Or is there anything that I can kind of clarify or kind of walk through again? Or any questions you guys have? The addresses should be different. Yeah, I don't know why those are. I think it might be because, I mean, we would have to probably dive into the handler. It must not be right, actually. I just noticed it right now. But it could be that somehow we're the from and the to, we're not passing properly or something like that. Yeah, not sure why it's actually states because we have the messenger and then we have the receiver. Yeah, not sure why it's different, but it should be different. Any other questions? No? Okay. So what I'd like to do is maybe just take like a 10-minute break. And then what I'd like to do is kind of go into more in the front end, right? So the next steps is I'll kind of dive a little bit more into Next.js and show how we can kind of start building out a front end that will allow us to interact with our smart contract. Because I think a lot of times that's a missing link. Like if you start making a smart contract and you do all this cool stuff, like you can use Scaffold ETH, and Scaffold ETH is going to do a lot of that generation for you in that debug contract folder. But that next point where it's like, oh, I want to start building out a UI and I want to start making changes to my contract and read values from not only from the graph, but also read values from Ethereum and display that content. So I'm going to talk about WAGMI, which is a popular kind of component library for Next.js, and then I'm going to talk about ETH hooks and Scaffold ETH components, and we're going to basically start building out a front end inside of that section. But yeah, let's take like 10, 15 minutes, take a break, and then we'll come back. Sound good? Awesome. Okay. All right, I think we can get going. Um, all right, so yeah, the next portion, what I want to go through is kind of diving into the front end, and then eventually we want to take our smart contract, deploy it to a test net, and then also deploy our subgraph to the subgraph studio with the hopes that eventually we'll publish it to the decentralized network, right? So I'm going to kind of walk through that a little bit. So yeah, basically when you're first kind of getting started with Scaffold ETH, you're using a lot of the front end that is kind of built for you, right? You're using this kind of like way to like iterate on your smart contract and then test your changes, test your kind of assumptions as you're building your smart contract. But eventually you want to like make it a little more polished, right? So this home folder is kind of the good place to start building that out. And so the way that the package is set up is if we go into Next.js and we go into pages, index.ts, I think that's the right page. Let me just make sure. Yeah, Next.js pages, index.ts. So we can basically take this page, we can kind of gut it. So I'm going to rip out, well, I'm just going to actually replace everything with what I want to put in here. So what we're changing here is we still need to use next for the next page for Next.js, and we still want to use the meta header, but we want to add in some additional imports, okay? So these are all ones that come in and are available to us in Scaffold ETH. They're already installed. One is WAGMI, which stands for We're All Gonna Make It. It's kind of a development, like I said, a front end kind of component for you that allows you to do things like read from the blockchain or read from a smart contract. We're also going to use Scaffold ETH components that are kind of also available and deployed. There's particularly an address component, which allows you to get an address. There's an address input, and then there's a balance function. And then there's these Scaffold ETH hooks as well that allow us to get like the account balance, the deployed contract info. We can read from the contract, and we can also write to the contract using those Scaffold ETH hooks. So those are really valuable because you don't have to write all of the TypeScript code to do this. And then we're also going to use state because we're going to keep track of some stuff inside the UI. And then we're also going to use Apollo, obviously, Apollo client. So we need to start GQL and use query. So we've kind of gutted this. We can save it, kind of show how we just kind of like wiped everything out right there. And so we have like a good starting point. This is probably where we get a little more kind of copy paste because we're going to start kind of like adding in some components here. The first thing I want to show is the ability to add some address components. So we can do that by creating some divs and then add in these two. One is the address of the actual contract, and then one is the balance. And you can see that we can just pass in the address here like this. So let's kind of just drop that in there like this, save, and then take a look at, I need to close some of these actually. Did I put it in wrong? Oh, we also need to grab the actual, we need to actually, so these are like, this is like empty data, so we actually need to grab the address too into a variable. So we can do that just by above the return. So we can put that here. I think I put it in the wrong place actually. Sorry, it needs to go here. So the address is we're gonna use the use account, which is a function of WAGMI, to be able to get the address of the smart contract. And then we're going to instantiate those and display those in the UI using the address and the balance functions of the Scaffold ETH component. So we save that, kind of go back. And then we can see here that we're able to get this nice kind of clean looking blocky that keeps track of like, the address and creates this little blocky hash. And then we have this little copy function. This is just a value of using Scaffold ETH components as they have these things built into them. And you could dive in and make changes to that stuff if you wanted to. It's all inside of the code, inside of the components folder. And then we also are keeping track of the ETH, which is the current amount of ETH for that wallet that's connected. So if we were to come here and disconnect, then that would disappear. If we were to connect back to our burner wallet, then it would reappear. Okay, so it's kind of reactive, right? Then we want to also create a div that shows the greetings. So we can copy that and put that right below. In this case, we're going to do it here. And they also said we need to get that greeting data. So in order to get that, we can do a use scaffolding contract read, and we can put that right up above here like this. So here it would have been just empty data, but we want to get that greeting into a data object here. So to do that, we're using use scaffold ETH contract read, which is a component of ETH hooks here. And we're passing in the contract name, which we know is called your contract. And then we're passing in the function name, which is the function, the getter function, which is the greeting. So if we save that, and then kind of go back, and I'm just kind of copy pasting this stuff because it's just easier to see, and then see how we get this kind of like building unstoppable apps, which is basically the value that we have right here. Right? And then we can kind of go a little bit further, and we can say, all right, now we want to create maybe like, let's say you want to create address and balance components for the contract itself. So we can add another div right below that, right here. Same thing, we also need to get the data for the your contract. And so in order to do that, we can also use scaffold ETH to do that. So we can come here, add another data object. So in this case, same thing, we want to get the data into a object called your contract. And to do that, we will use deployed contract info and pass in the contract. So, and then we'll get back the address and the balance in here after we pass it in. So the same thing goes here. Now we have the balance. So if we look over here at the debug contracts, it's basically the exact same thing that you're seeing here, which is the contract address, and then the current contract's balance is displayed here as well. And so again, you might do this in your own like pretty way with CSS and all that good stuff, and like rearranging it. Just for the sake of understanding some of the front end stuff, we're just going to kind of walk through it. And then the last thing, or the next thing we want to do is also create some way to actually update the greeting inside of the thing. So like as of right now, if you were testing, let me just close this for now, you would go to the debug contracts and then you would make a change right here. Let's just say you wanted to do that this way. We can grab this entire div and we'll walk through what it does. But essentially we have a new div that is going to keep track of well, here it's going to actually allow us to set the value of the new greeting. It has a placeholder, so we're going to need to use state for this. And then it has a class name called input. And then we have a button that is going to allow us to make a change to that data. And so in order to do that, we need to use state. So we can do that right here. Put that, I think we need to do it right here. There we go. So in this case, we're using use state. So if anyone doesn't know use state, you basically need some way to like keep track of, as you're typing something into an input field, we want to be able to keep track of what that new greeting is going to be. And then here we're able to use the scaffold contract write, pass the same thing, pass the contract name, pass the function of what we care about, and then pass arguments. So the difference between this one here and this one is we also need to pass across the new greeting, which is being passed across and kept track of the state. So here we're keeping track of the state. Here we're passing in the state as it's available. And then on click, we are setting the greeting. See if that works actually. I don't know what it's. There we go. Okay, so we can go like foo, set greeting, and it was successful. So now we have this like button. We can also just double check to make sure it was updated. And there it is. And there's the update. And then we can do something even more. Like we can actually do the same thing for the send message function. So we can grab this code, paste this right below. Essentially, we're going to be doing a address input. So this is an additional component also of scaffold ETH hooks that allows us to, I think it's scaffold ETH hooks. Sorry, it's components, which is going to allow us to have an address input field. And same thing, we're going to need to keep track of state. But in this case, we're going to need to keep track of two states. We're going to keep track of who the actual receiver of the actual message is going to be, which is here. And then we're also going to need to keep track of the message that we're typing, right, as we type that in. And then we're going to use the onChange here to do the click to actually send the message, right? So to do that, we can grab this state code here, put it right below. So in this case, what we're doing is we are keeping track of who the new receiver of a message is going to be. what the message is going to be. And then in this case, we're kind of expanding on this idea of like passing in arguments, and we need to pass 2 arguments, right? Because this function, the send message, not only takes an address 2, but it also takes what the message is. So we have those additional arguments that we need to pass here. So we can save that, and we can take a look and see what that looks like. So we go to home, and now we have this vitalik.eth right here. And then we can send the message and say, hey, how are you? And then hit send. So you can see how we can start building out our UI based on what we want to do, kind of using these components that are just native to Scaffold ETH, right? And then the last thing we want to do is let's start using GraphQL to keep track of our messages, right? So you'll create your smart contract, you'll create your, your fields and your buttons to interact with the smart contract and propose transactions. But when you start getting the data from GraphQL, we want to do that. So I kind of created this like table, which kind of just shows an example of how we can display that front-end information. So right below this div, we'll drop this in. And the way we're going to do this is it's just a basic table with a header, which keeps track of who it's from, who it's to, the message. And then we have these data table objects that are going to be who the message was from, who the message was to, and what the actual message was. So we just need to get this object filled right here to be able to map that data and display it in our front end, okay? So to do that, we can use, same thing, we can use, as I showed you earlier in the example UI where we're creating a GraphQL query, we're gonna use that up above here to do that. So we need to put that up above actually over here to be able to create the query. So in this case, we want to get the first 10. And we can do some interesting things like the descending order. We can also order it by a certain field. But in the end, we want to get the message, who it was from, who it was to, and then what the ID was, right? And so the next thing would be to actually load that stuff into data. So we can do that here. And so here what we're doing is just keeping track of, well, we're using the query right here to get the messages. And we're creating an object called messages data. And then here we're creating a map or an array of that data that is available, okay? So if we save that, we should be able to come over here and hit refresh. And what did I do wrong? I missed something. Let me just grab this whole thing, make sure I did it right. The link to the whole file is here, so if for some reason you didn't paste something in the right area, you can kind of look at this example and just grab it. So let me do that. Save it. Okay. So now we can see that we're able to get this data. So this is actually coming from GraphQL that is running inside of the graph. So inside of our Docker instance. And so we can actually see where that is by looking at the configuration file for the application. So if we go here, we go to the app, we can see where our subgraph URI is. So you see right here, we're pointing the URI for the Apollo client to the local instance that we're running in Docker on port 8000. And that's important because when we ship our app to a testnet, obviously we're going to need to update that because someone's not going to have access to our instance. So we need to consider that. So we've kind of built out this front end, and now let's just say that at this point we're ready to send this, right? So we've kept track of our messages, and the data's here is proper actually. So it looks like I did it right. My query was off before because this is keeping track of who it came from, who it went to, and then what the message was. It's not very pretty. I didn't say this would be a CSS class, so it's just more of like guidelines of how you can start building out your dapp. But we got the data that we care about. So let's just assume like at this point, we're to the point now where we actually want to take our application and we want to ship it out to a testnet, okay? So we've gone through, we've built some changes to our contract, we've deployed our subgraph and tested it locally. So we're pretty confident that when we deploy our subgraph to the decentralized network, that it's going to be good, right? We've gone through, we created some UI stuff and showed how you can like kind of plug up your smart contract functions with your front end. And so now we're to this point where we want to ship it to a test net. Now, everything we've been doing is locally, and everything we've been using has been with hard hat for the most part when it comes to like Ethereum transactions. All these keys that are in hard hat are shared. So literally, like if you were to deploy this using the existing deployer key, everyone would have access to it. And in order to deploy it, you have to fund the deployer account with some ETH to be able to pay the gas. Okay, so that's a problem because there's someone constantly listening for these addresses and withdrawing the funds from them, basically. So we need to create a special deployer account. Okay, so to do that, there's a cool command called yarn run generate in scaffold ETH. And if I can type properly, what it's going to do is it's going to do exactly that. It's going to create a private key for us. So it's going to randomly generate a private key, and it's going to save it in our environment file, right? Then I can do a yarn account like this, and I can get that particular address. So in this case, I have a address that's available here, and I can just for simplicity, I'll just grab the address here, and let's go to MetaMask real quick, and let's do it on GoEarly. I'm going to send some GoEarly ETH to this address, and I'm going to send 0.05. I don't need to send a lot, and I'm going to send it from MetaMask to. So in my MetaMask wallet, I have 4.49 ETH. GoEarly ETH, it's fake ETH, but I'm going to send that over to the deployer account, and now it's done. So now if I do yarn account again, we'll see all of our balances, and the one that we care about is GoEarly, and there we go. So we have a balance. So it kind of goes through and checks all of our balances for us on all the accounts. So I've created this deployer account, and now I'm going to use that deployer account to deploy my smart contract. All I need to do is just do yarn deploy -- network GoEarly, like that. So we've been deploying our smart contract to hard hat. If I don't specify network, it's just going to deploy it locally to localhost. But now I've said, okay, let's ship it to GoEarly. So I'm using the deployer account. I'm shipping my dapp to GoEarly. It might take a second for it to load, but there it goes. It was successful. So now we can look where it was deployed to. So now if we go to GoEarly Etherscan here and do a search, we can see that there was 15 seconds ago I deployed, and here's the contract. Now, remember what I told you earlier is when the contract's deployed, it's deployed in bytecode, right? So this is what the contract looks like on the blockchain, right? To be like super optimized and lightweight. And so we need to verify the contract. Like the first thing you should always do is verify your contract so that people can see your smart contract and see what's going on. So luckily, there's a command to do that really easily. So we do yarn verify -- network GoEarly. So what this is going to do is going to compile the smart contract. Well, it's going to send off the, I think the ABI to Etherscan, and it's going to compare the ABI to what was deployed to make sure that they match, basically to make sure the bytecode matches. So now if we come over here and we look at contract, we can see our contract. So we can see all of our changes, we can see all the stuff that we've put in here, and now it's a verified contract. And that's important because when we're going to go through the next step to actually publish our subgraph to the studio, we want the CLI to be able to read in the ABI from Etherscan. Okay. So let's go ahead and do that. So the next step would be, before I forget that, let's also go to the front end and let's update our front end to point to GoEarly. So inside of the Next.js package, there's a scaffold config right here, and there's a chains option. So all we have to do is change this to GoEarly, like that. And now if we go to our front end, we'll see that now we have our app deployed, right? But we don't have our wallet connected anymore. We don't have access to the burner wallets anymore because why? Well, we're on a test network now. Our front end is pointing at the test network. So we can either use like Rainbow or Wallet Connect. I'm going to use MetaMask just because it's easy. And then there we go. So I connected. And then earlier we saw my MetaMask that I had 4.44 ETH. Here we go. And now we're able to interact with our contract. Now this data is wrong. We're going to need to fix that in a second. But first, we have to ship our subgraph because this is still pulling locally. We're going to fix that in a second, though. But we could make changes to our contract here if we wanted to. We could say, hello from SF, set greeting. And I could sign the transaction. And now it's going to obviously take a little longer because everything we were doing before was on hard hat. But now we're actually proposing a transaction on the Goerli testnet. So it has to be mined or validated. Sorry. Oh, there we go. So we can see that it updated. And we could also check out the transaction if we wanted to see. And we can see here that it was successful. You can see how much gas I paid. And we can see it's hello from SF. It's been updated. So now this is on a public testnet. I can also send a message to Vitalik.eth. You are cool. Send. There we go. Confirm. Same thing. Got to wait. But we're proposing a transaction, and it's successful. Okay, so the next step would be that we need to build out our subgraph and deploy that subgraph. We've already kind of built our subgraph, but I'm going to show you the way easier way. Earlier, we did it all by hand, but we're going to go into the graph.com/studio, and we're going to create a subgraph. We'll call it workshop 2, and we're going to select a blockchain. So we are on Goerli. So Goerli is right. Where is Goerli? Here it is. Oh, no. There it is. So create a subgraph. Okay, so we have workshop 2. That's what we're calling our package here. We could name it whatever we want. We can change the image, kind of some cool stuff. But what I want to highlight here, you can add a description. You should put your source code in there if it's a public subgraph, but we'll get to that in a little bit. Here's where the magic is. So this thing walks you through exactly how to take a subgraph and put it on the network. So first thing you need to do is install the graph CLI. So we've been using the graph CLI that's kind of built into our package, into our mono repo, but we want to install it globally because we want to use the newest version to do this. And so we can do a yarn or npm command to install that. I've already done it, so I'm not going to do it. And then let's open up a new window. Go to projects, the graph, and we're going to do it here. We're going to initiate a new repository. So we don't want to do this in the Scaffold ETH repository because it is also a yarn package. So we're going to create a new one. So we're going to do it here called workshop 2. We're going to choose the chain. So this is an Ethereum chain. And we can name it whatever we want. And we can save it in workshop 2. Oh, workshop 2 exists. Workshop 2 subgraph. And then we choose the network. So what were we on? We were on Goerli. Here it is. And then it wants the contract address. So we have that, right? So we can go to Scaffold ETH and we can grab it. It's right here, right? Copy it. Let's paste it in. So this is the magic part, is it grabbed the ABI because we verified our contract for us, but it didn't know the start block. So it didn't know when I deployed the contract. That feature is not there yet. It's coming soon. But what's important to know is we can look at the contract and look at this creation right here, contract creator, and we can click it, and it'll give us the start block. So as the Ethereum chain grows, more and more blocks get added, the block increases. So we don't care, because our smart contract, we just deployed it. We don't care about all the previous blocks. We only care about when I deployed my smart contract. So we're going to put that in here, and then we can name it. We'll just name it contract. And then this is the secret sauce. Do we want to index the contract events as entities? We can say yes. And what that's going to do is it's going to read the ABI and automatically build our subgraph for us. Okay. So all that stuff we did earlier where I put it in and showed you how it works, that was just for you to understand the process. You can do it all automated. So do we want to add another contract? No. Okay, so now we have this workshop 2 subgraph. We can come in here and we can continue down the path of what we need to do. So first thing we need to do is authenticate here. That. Now we're authenticated to the API. So this is my API key. And then we can go into here and then we can do a code gen and graph build. So it's the same kind of commands we ran earlier with Docker, but we're using CodeGen to generate the code and then build to build out the subgraph. So it's going to do that for us. And it did that for us. And then all we need to do now is actually deploy it. So we can come over here and just do graph deploy, use the studio command, and do a version, same thing. So we'll do 0.0.2, I think we were on. Let's do that. Excuse me. So now it's taking my subgraph configuration that it automatically generated for us, and it's shipping it to the Subgraph Studio, and it gives us a publicly available now endpoint that we can query. So let's take a look at it. We can grab it, we can come over here, paste it in, and here we go. Now we get a GraphQL interface just like we had before, and we can start looking at interesting stuff. So in this case, we have the greeting changes and the messages. So it's a more minimal subgraph than what we had before because I guess I was doing a little more complex stuff in the examples that I had before. But same thing, we can say send messages, the message, the ID, and then like first 10, hit play. And there we go. We got the message that was sent to Vitalik that says you are so cool. If we wanted to, we could get who it was from and who it was to. And there we go. We get that data available. And we also can see the greeting changes at the same time as well, by the way. So if we want to get the greeting changes, what the new greeting was, who the setter was. So now we can do one GraphQL query to grab two different completely event data sets using just one simple HTTP query over GraphQL. Very powerful, right? So the next thing we need to do is take our front end, right, and update that the URI. Okay. So if we go to Subgraph Studio, you get a development query URL that you can use. This is actually still using the hosted service. We've deployed our subgraph. We can see that it's 100% synced. So it's already indexed the events because we saw the data, right? The next step is if you were to actually deploy your dapp to like a mainnet, you would want to publish your subgraph. And this is where you would curate your subgraph and pay some GRT for the indexers to pick it up and keep it on the decentralized network. And then you can use the API key to query the data that you need. But we can just use this development URL. So let's just grab that. Let's go back to our front end. Let's go to that app page here. And then here. Like that. Save it. Now, it's going to break because I know that the data object is not proper. What we care about is not properly because we changed the syntax. And I think I covered that in my workshop, but let's just take a look real quick. So we did the deploy. We deployed, in this case, I was doing Spolia, but we did go early. That's fine. We deployed the subgraph. We authenticated. We deployed. And we did all that. So now we can see, well, let's grab this data query instead. And let's paste that into our index ideas. Yeah. Let's see if that works. I think it should work now. Let's. Pretty well received. Yeah, I'm not sure why. Spolia. Oh, okay, yeah, so here we need to fix this. So before we were getting, we have a different data structure because our subgraph changed. So we also need to upgrade our subgraph to do it properly. So we need to kind of update the front end a little bit here. So let's kind of go here first of all and go to where the data object is. It's here. I think it's the same. Just a little different. It's just named a little different. And then we can change the query as well. That should be right. And then we need to update the table. That's the thing. Okay, so we're going to grab the table. and we're just going to put in the new table. So again, because our we can get rid of that one. There we go. Now let's do it. There we go. So now we're getting the data that we needed. And that's just because when I generated the GraphQL subgraph configuration, I should say, and deployed it, it was just in a different data structure. It had different entity types. It had different namings. So I just needed to update my front end to point. But now we're pulling this data directly from the subgraph studio using GraphQL, right? And so if we were to send a bunch more messages, we could, let's see, shutterblock.eth. So we send a message here. Oh, okay. For some reason it was doing this for me. Let's try it now. Confirm. So we should be able to see that data automatically populate. I probably don't have the code proper where I need to see if it finished. There it goes. I got to refresh, but let's see if it's there. There we go. So it's automatically been indexed and it's available over that endpoint. Cool. So yeah, that's pretty much the whole workshop. The last part would be maybe you want to deploy your front end somewhere. So there's a command called yarn vercel, YOLO. So we can do that if we want to, like this. I'm in the wrong package. Yarn vercel YOLO. What it's going to do is use vercel. So we can say set up and deploy, yes. We can name it whatever we want. Link to an existing project, no. We can call it just workshop 2 and set it up. And then what this is going to do is take the front end and deploy it to vercel. So it bundles up the front end, index, the HTML, the CSS, the JavaScript, and then it ships it to vercel for you. So then we'll have, as soon as this is done, it might take a sec. It essentially will deploy it in a publicly endpoint that you can share with people. This is not the true Web3 way. The true Web3 way would be to deploy it to like maybe Arweave or IPFS or something like that, so that it's a truly decentralized application. Yeah, but that's it pretty much. If we waited until that would be done, then we would have a public endpoint. There's lots of really useful information in this blog as well here at the end. How WAGMI hooks work, I would recommend looking at that because we do use WAGMI in Scaffold ETH. There's also documentation for the Scaffold ETH hooks for the components. There's some more detailed README and assistance that you can go through here. All my contact information is here. I have a mirror XYZ that I post to every once in a while. Lots of stuff about Scaffold ETH, a list of all the workshops that we've done on Scaffold ETH, a bunch of workshops on the graph that are available on YouTube. And then there's some really interesting like learning utilities or your learning platforms. One is the Zero to Build Guild. It was written by a build guilder on his experience going through the build guild and different things and pathways you can learn. There's also Austin's Web 2 to Web 3 curriculum, which is really, really useful. It's a series of videos. And there's also a Nader Dabbit who used to work for Edgenode actually, has a really good resource with lots more information. So these are all just really good resources to kind of take you to the next step as you go. What kind of questions? Does anyone have any questions about the workshop or anything that I can clarify? No? Those are good? Cool. We'll hang out a little bit longer and we're going to have drinks and some food. And thank you guys so much for coming. Appreciate it.